Hello students, welcome to the 64-bit edition of the SecurityTube Linux Assembly Expert course and certification. This is module 1 and in this video we will look at how to extract CPU information. Now, as I'd mentioned, different processors speak different assembly language. What that means is the Intel family has a very different assembly language from the ARM family or the MIPS family. And this is very important for you to note. Now, a C program with the right toolchain, you could pretty much port it on multiple processors with probably the core program remaining pretty much the same, right? With hardly any changes, in most cases, no change at all. Unfortunately, in the case of assembly language, if you want to port a program to an absolutely new processor family, you would pretty much have to rewrite it from scratch. Now, we will only be concerned with the Intel architecture, and the IA32 or 32-bit assembly was already covered in a separate series, which is a course as well as available on Pentester Academy. In this video, we will be concerned with the 64-bit architecture, also commonly called x86_64. So now the question arises, if you are logged on to a computer, how do you even know that the CPU supports 64-bit mode? So let's go down to our little Ubuntu VM and let's open up a terminal. Now, in order to look at what the CPU is and what it supports, just do an ls CPU and you would actually find a bunch of details. The interesting ones for us is the architecture is x86_64 and the operational modes include both 32 and 64-bit, right? This VM is 64-bit while the host machine is 64-bit as well. Now, if you're using any of the latest, laptops and desktops, there's a 99.9 recurring percent chances that it's a 64-bit CPU. There are other ways by which you can also go ahead and figure out different things about your CPU. The most common one is cat proc CPU info. And this gives a ton of information about the CPU, including the model name. So I have an Intel Core i5. There's also a bunch of other information in here. The one which is interesting for us is the flags, because this typically talks about extensions and capabilities of the processor. So we can clearly see it has an FPU. We can also see that it supports MMX instructions, SSE, SSE2, a bunch of other things, and importantly LM, which is long mode, which typically indicates that a 64-bit mode is supported. Now, later on in this series, we will look at how we will be using MMX and SSE instructions, etc., to also write shellcode, right? So this is a quick preview of how you can go ahead and figure out more information about your CPU. Let's get back to our slides. So I've already talked about proc CPU info. Now, for almost the whole of this series, the tool which I will be using a lot to look into what we are doing, how the processor executes, step through instructions, freeze the state of the program and all of that using GDB or the GNU debugger. Now, this program is pretty much going to be installed if you've used the apt-get build essentials. So you have nothing to worry if you've already done that. And GDB is pretty much the de facto tool for debugging programs on Linux-based systems. Now, I already have put out a GDB series on Pentester Academy, and if you haven't gone through it, I would highly recommend that you first go through it before proceeding, because a lot of things while working with assembly language and later with shell coding, I would be taking for granted as far as GDB debugging is concerned. So please go through it. Now, how do you know if you're already good enough with GDB for the rest of the course? So I've created a very simple GDB test. And if you're able to solve the test, I think you're pretty much in decent position to move ahead with the videos. So let me run you through what the test is. You can download the zip file from the link just below in this video. And this should give you a file called gdbtest.zip. Let's unzip it. And let's go into the directory gdb test. And there is already a binary file called gdb test, which is a 64-bit ELF. Let's go ahead and run it. It just requires one argument, which is supposedly the passcode. Let me put in hello. And if you notice, it says it's time to review those GDB videos again, right? So what do you need to do? Now, to make your life easy, I have also given you the C program from which GDB_test was created. Now, it's a very, very simple C program. Even if you aren't from a C background, you would probably figure out what this does. I've gone ahead and defined a character pointer here, which points to a string called pentester academy pass. And then all I do is do a string compare between the user input as well as the string pentester academy pass. Now, if both the strings match, welcome to the SLA 64-bit course. Please proceed to the next video gets printed. If it doesn't match, it's time to review gets printed. Now, even though you know the passphrase which you need to enter, the test is really, and honestly, it's a self-administered test. So, you just need to be honest with yourself. The test really is to go ahead and enter anything else apart from the true passphrase, right? Pentester academy pass. So you can enter anything else apart from the correct passphrase, and you can do this within GDB. I do not require you to exploit this program or write something super cool in Python, which kind of inject something inside and changes stuff at runtime. You do not need to do anything out of the ordinary. All I want you to do is open the program up in GDB and to go ahead and do something so that once you eventually run the program, so let's say I run it with run hello, you can debug or do whatever you want in between, stop the program, change variables, change memory location, whatever you need, please go ahead and do it. However, the end result should be that rather than printing, it's time to review those GDB videos again. It should print, continue, and start viewing the remaining videos, right? And I think if you fail in doing this challenge, you should go back and review the GDB videos and do some Google searches. Now, there are multiple ways to solve this, and one of them kind of goes ahead and requires you to dive deep into assembly language. Please note, even though many of you may have already taken my class on assembly, the 32-bit one, or may already know assembly language, this specific test can be done without writing a single, without looking into a single line of assembly language inside the binary GDB_test. However, feel free to use any solution that you like. And if you think you have an interesting solution, you can create a YouTube video or a bunch of screenshots and CC us at SecurityTube on Twitter and we'll retweet it, right? So guys, that's all I have in mind for this video. And take the GDB test, and in the next video I'll give you the solution. However, if you fail this test after taking it yourself, please go back and review the GDB series, or else I can assure you, you will be lost in the rest of this course. That's all. Thank you very much. Bye bye.